Hey, well done! That's a really important result, so we'll revisit it here. Mass m initially at x0 with velocity v0. Constant total force F in the x direction accelerates it at A equals F over m. Constant force gives constant acceleration, so we can use equation 3 from kinematics to relate the displacement x minus x0 to the initial and final velocities. The total force is constant and parallel to the displacement, so the work is F times x minus x0. Substituting for Newton's second law, we have work equals ma times x minus x0. But remembering equation 3, let's multiply by 1 and write the 1 as a half times 2. Now we can substitute for 2a x minus x0. That's just v squared minus v0 squared. So now we have total work done equals a half mv squared minus a half mv0 squared. This is the change in the quantity half mv squared. That is such an important result that we give that quantity a name. We call that quantity the kinetic energy. Kinetic energy is defined as a half mv squared. What we've just proved is that the total work done by all the forces acting on an object is equal to the change in its kinetic energy. Actually, we've only shown this for constant force in one dimension, but it's true for variable forces as well, and it's called the work-energy theorem. Again, let's check the units. mv squared is kilograms times meters per second squared. Take one of the meters outside and use Newton's second law to remind us that kilogram meters per second squared is force, units newtons. And newtons times meters equals joules. Let's do a question to get used to the units.